Welcome to the 9th video in our series on electrostatics for grade 11s. By now you should have looked at this this YouTube clip already, electric field patterns. You need to do this before you carry on watching this video, because you're not going to understand what's going on. So you should have a knowledge of fields between two charges, either two like or unlike charges. You should also have an idea that electric field around a point charge, what it looks like, as well as the uniform field between two parallel plates. You should also be aware that we draw field lines. When we draw field lines, we always draw it going away from the positive, in other words the direction in which a positive point charge would travel, and the closer they are, the stronger the field, and they're drawn perpendicular away from the object, whatever it is that it's on. So you should have an awareness of that. So what we're going to be doing today is we're going to be doing electric field strength, the electric field strength, and it's quite fast. It shouldn't take us too long in this video. It's not too difficult to understand. But the electric field strength can be defined as, at any point electric field, the strength of the field is measured by the force exerted on 1 coulomb of charge placed at that point. So electric field strength is the force applied to 1 coulomb of charge placed at that point in the field. We can rewrite this equation by making force our subject, so F is equal to Q times E. Alright, so that's a very basic one. Force is measured in newtons, Q, charge measured in coulombs, and electric field strength is newtons per coulomb. We also know that a pattern for the field around a point charge shows that the field strength of that point charge decreases as the distance from the charge increases. Now, if you understand point charges, and I'm going to draw one for you. Here's a point charge, and the field, let's make this a positive charge. Okay, and the field that runs away is like that. So the further we get, so let's take 2 points. I'll take a point. The first point is in red over here, okay, and the second point is going to be blue further away over here. The field strength actually decreases the further I get away from a point charge, and I'll show you why. Because you already know that if it's a strong field, the field lines are drawn closer together. So just have a look. As we go away from a point charge, the distance between the line gets bigger and bigger, and therefore the electric field gets weaker and weaker. So at this point, it's much closer than at this point. And so the electric field strength decreases the further we get away from the point charge. And so we can write E is equal to K Q over R squared. Sorry, put the squared in. So it's KQ over R squared, where E is the field strength, obviously. Q is the charge which creates the field. It's not this charge over here and over here, but it's this charge over there. Let me maybe make that in a bright green. It's this one. That's the charge that we're putting in over here. It's the one that's creating the field, not the point being placed inside the field. Okay, make sure that you don't make that error. Then we also have field strength in a uniform field. So if we've got two parallel plates, let me draw that. I've got two parallel plates, plate 1, plate 2. You'll know that the field runs something like this. Let me use a gray, not such a black, so you can actually see. There's my field. And although I'm not perfect at drawing, these lines should be sort of equidistant from each other, indicating. Okay, so I'm going to make this positive and that one negative. Then we know that it'll always be in that direction. Okay. Alright, so that's electric field strength. So we know that anywhere within that field, the field strength should be the same because these lines are equidistant from each other. Sorry about that. So that should be equidistant from that one. So therefore you should have a uniform field strength. But we'll see later that the field strength depends on the potential difference between 2 points and the distance between them. So it depends on the potential difference, which is the voltage between these 2 points, as well as the distance of these 2 plates. So if we have to rewrite this equation, E, electric field strength, is equal to V over D, where the potential difference is measured in volts and D is the distance in meters. So you're going to have volt per meter as my unit, or you can use newtons per coulomb as well. So these two are actually equal to each other, and you can try to prove that for yourself. It's a good exercise. I think it is one of the questions in the exercise that you're going to have to do. And that's electric field strength. So make sure that you've watched the video before this, else you're not going to have understood a word that I've said now. And then look at this video, then complete Think Tank 11.3 in class, as well as exercise 11.2 in class, and call for help if help is needed.